Hi class, let's take a look at problem 6. Now, notice that on problem 6, this specific one, it's not just the regular x, it has the absolute value. So this one represents distances that are less than 4. So let me put technically both of these points on the number line. Remember that when you're looking at distances, you're looking at the right hand side. So 1, 2, 3, 4. And I'm going to put an open circle because it says less than. And then 1, 2, 3, 4, which is technically, well, the values of 4 and negative 4. Also, because of the nature of the inequality, this one, we're going to actually graph the lines x is equal to 4 and x is equal to negative 4. So this particular one is going to represent all the coordinate points that happen to be vertical lines. So our boundary is going to look as follows. So let me actually insert the lines. So we're talking about vertical lines, and they're going to be vertical and shaded lines. So let me just make it a little bit thicker. And then let me copy it. I think this will make it a little bit faster. Okay, so there we have the boundaries of the distances x and y that are less than 4. Now, notice that they do want you to provide a solution set. A test point for the solution set. And in this case, let me just select the origin because it'll be easier to evaluate. So for this one, our test point is going to be x and y, which is equal to 0, 0. As we plug it in, we only have the x's. It's less than 0, so less than 4. So technically we're looking at, as we plug them in, the values of 0 is less than 4, which is actually true. And in this particular situation, well, we're looking at all the distances that are less than 4. So not just any value less than 4 or less than negative 4, but all the coordinate points that are in between here. So this is what problem 6a is going to look like. All the distances x and y that happens to satisfy x less than 4, that's just going to be the numbers in the middle. Notice that if we had tested a point on the outside here or here, so let's say we would have selected 5. 5 is not less than 4, so this would be false. Also, this would be false. They only want one coordinate point, so we don't have to graph the other ones. Let me show you what this one looks with technology. And in this case, we're looking at, well, vertical lines at 4, and then technically every coordinate point shaded in between. That's it for problem 6a. Let's move on to technically b, and in this case we're also going to graph y is equal to 5 and y is equal to negative 5, and it's going to be with dotted lines. So let me just put the coordinate points so I can have them as a reference. So this is going to be 1, 2, 3, 4, 5, open circle. 1, 2, 3, 4, 5, open circle. And let me insert the lines. And I think the previous graph moved. Let me put it back. Okay, there we go. And let me make this one larger. Also, it's going to be dotted. Okay, let me copy this one. Okay, and before we select the test point, notice that the coordinate point actually reads greater. So any coordinate point greater than 5, it's going to be up here and technically up here in terms of absolute value. So our solution, it's going to be the shading of these. Now, let me select the test point and let me select again the origin. Uh-oh. So as a test point, x and y is equal to 0, 0. As we evaluate 0, 0 into absolute value of y is greater than 5, you're going to have that 0 is greater than 5, which is technically false. So this means that selecting a coordinate point in the origin or in the middle of the lines is false. Any point above it would give us a true statement, and any point below it will give us a true statement. I am putting the coordinate point because, well, they want at least one. And then let me show you how what technology this one looks like. And as you can see, oh, I have a typo because it says 5. This value here should be 5. So that should be 5. And this value should be 5. Let me show you how it looks with the actual graph. Okay, this is what it should look like. And I did have a typo. I had 4. You can kind of see here that, well, this is absolute value greater than 5. There's your 5s on these two. It still has the same shape. You're going to have technically 2 horizontal lines and then shading above it and below it. Let me display once more the actual solution for the sketches. Okay, sorry you guys, it's not letting me put it on one set. Okay, so this is what it looks like. Now I keep refusing, it keeps jumping into the next page. But you can kind of see here the lower bound where we're shading above this line and below that line, and then in between those two. That's it for these problems. I'll put the rest of them in another video.